So today we are going to do factor by grouping. And again, you'll notice that I'm just using, again, my favorite space is Kuta Software for worksheets. Okay. I didn't download the notes because I could figure you could just go and print these off for yourself right here at the website. Okay. So looking at problem number 1, this is factor by grouping. The first thing that we did was we used greatest common factor to factor. And now we're going to use greatest common factor by grouping. Okay, so by grouping, what does that mean? That means that I'm not going to look at the whole problem all by itself. Why? Look at number 1. Can I find a greatest common factor for everything? There's an 8 there, there's an 8 there, there's not an 8 there. There's an R there, there's an R there, there's an R there, but there's not an R there. So there is nothing that the whole thing has in common. So what you do then is you try and group it 1 or 2 pieces at a time. Is there a greatest common factor for just those 2 pieces? And yes, there is. We notice that there's an 8 there for the 8 and the 64. And we also notice that there's at least an R squared here and an R squared there. So what we're going to do is we're going to ignore that for the moment, and we're going to write down on our greatest common factor of 8R squared for these 2 pieces, and that leaves me with R minus 8 in my parentheses, just like you did for the last time's homework assignment. And now we're going to look at these 2 pieces and see if there's a greatest common factor. Well, there is a greatest common factor. There's always one. And the greatest common factor can always be considered 1. I don't really use it unless I have to for this, but I need to use it here because the greatest common factor is 1 for just that group. So I write it as 1 times parentheses R minus 8. Now the difference between greatest common factor for the whole thing and greatest common factor for grouping is that now that I have my groups together, I notice that this set of parentheses is the same as that set of parentheses. Parentheses means multiply, so this is actually a greatest common factor all by itself. So I'm going to write it out in front, just like I do with all greatest common factors. Remember, this and this gets put in a stack together and put out in front of the parentheses. And then my leftover is 8R squared plus 1. And you're done. So let's try that again. Let's say problem number 5. Looking for a greatest common factor. So there's no variable here, so I know that there can't be a greatest common factor of an n, first thing. And I'm looking for a number that will go into 63, 54, 105, and 90. I can't think of one right off the top of my head. It may turn up somewhere as we're looking. So I'm just going to look at these 2 right here and see if I can't find up with a greatest common factor for those. Okay. And this is 9 times 7. And this is 9 times 6. And this is an n cubed and an n squared. So this would be a 9n squared. And that would be 7n plus 6. So those 2 are taken care of. Now we need to go for those 2. Now our goal is to get a set of parentheses that's exactly the same. So I need a 7n in the front, I need a 6 in the back, and I need it to be positive. Well, I notice that this is not going to be positive, but I also notice that both of these have negative signs. So my greatest common factor at least has a negative sign in it, and that's going to turn that to a positive sign there. Because I took a negative, I'm going to take a negative, what is that? 6 times 15? I think. And then I started putting in there. Sorry, it's not there because there's not an in there. And then 15 times 7 would be 105. So that would be 7n plus 6. So then our answer then is going to be 9n squared times 7n plus 6 minus 15 times 7n plus 6. Sorry, just rewrote that because that looked a little bit messy. And then that's going to be 9n squared plus minus 15, sorry, and 7n plus 6. Now that was a little messy. Let's try it again. What if I had something like number 8? Looking for a greatest common factor. I'm looking and seeing that there might be a 5 for all of it, but there's definitely not a variable. So let's try the 5 first. That's going to be 21n cubed plus, let's see, what is 175? Get my calculator out here. 175 divided by 5 is 35 n squared minus 25 n, no, minus 15, isn't it? Minus 25. Okay, so I definitely don't have anything left in terms of greatest common factor for the whole thing there. So now I go to my factor by grouping. So let's just look at these two right here. I'm going to leave the 5 out there for the moment. Just look at these two pieces. Well, 21 and 35 have a 7 in them, and it looks like there's an n squared in both of them. So I'm going to try that. And that's going to give me 3n plus 5. Okay, let's look at those two then. Well, they both have a negative sign, and they both have at least a 5 in them. So I'm going to put that as a negative 5, and then 3n plus 5. Almost done. Here's another greatest common factor. They both have a 3n plus 5. So I'm going to use this 5, that 3n plus 5. And again, remember, they're stacked up there in this one pile. And then I'm left with 7n squared minus 5. So that's what it looks like in factored form. I do want to look at a question like number 14, because number 14 does something slightly different that you haven't seen in either one of those problems. So number 14, again, I'm looking for a greatest common factor for all of it if I can find one, and I don't seem to be, that 21's throwing me off, so I don't seem to be able to find one for all of it. So now I just need to look at that one. So I'm looking for a greatest common factor there, and it looks like I can find an 8 and an r squared. So this is going to be 8r squared and 3r minus 8. Okay, so that's about that taken care of. Now I'm looking at this part of it and trying to get my greatest common factor to be inside the parentheses. That's why I say number 14 has something different than you've seen before on those other two problems, or under 3 problems, because this negative sign, when I look at it here, is a positive sign. And in order for them to match, I really need that to be a negative sign. So what I'm going to do is I'm going to make sure that that's a negative 8 when I get done by taking a negative from here and negative from here. Because remember, positive 56 is minus a negative 56. So if I treat that like a negative and take a greatest common factor negative out, then this becomes a negative sign. So then that would be a 7, not an r, sorry. So then that would be 3r minus 8. So now my greatest common factors do match, and I'm left with 8r squared minus 7. I seem to keep on miswriting these. Let's try another one. This is the second page of that CUDA software worksheet. And I'm looking for, I had one while ago that did that. Where was it? I'm looking for something here. Yeah, number 19. Number 19, again, looking for the whole thing. There's no variable that's the same in all of it. There's no number that's the same in all of it. So now I have to go to factor by grouping. So looking just at this part of the problem, I end up with a 4 and a B as my greatest common factor. So that leaves me with 3C minus D. And now I need to look at just that part of it. But again, I notice that I want this to match and have a negative D there. And right now this is a positive D. So remember, this could be written as minus negative 5xd. So I'm going to take a negative 5x out of both of those, and I'd be left with 3c minus d. So my greatest common factor, 3c minus d, and my leftover 4b minus 5x. Okay, so that's factor by grouping. Don't care how many variables, don't care how many greatest common factors you can find. Again, you may not always find the greatest common factor at the very beginning for all of it. Sometimes you will. So keep working on greatest common factoring and factoring by grouping.